Good morning, Bitcoin. We're live from the Baltic Honeybadger in Riga. We're joined by Adam Back from Blockstream. How's it going, Adam?
Pretty good. It's a good conference, as last year.
It's great to be here. I never thought I'd be this north or this east, or that it would be this warm. The weather's been fantastic. I know yesterday I got to go see some of the sites, and I was surprised to wear short sleeves.
Cool.
So last year we talked about scaling. We were at the HCPP in Prague, and we had a discussion about scaling, and it was all about Lightning networks. I know we were talking just a minute ago, and it seems like it's going great for Lightning Network. It seems like it's rolling out. The wallets are getting easier to use. They're going to have less requirements to run a node, a smaller node that a portable wallet like a phone could use. So what are your opinions? How is scaling going?
I think Lightning is going pretty well, and we've yet to see the technology fully mature. The wallets are still improving. So Shesek, who's an independent developer that we work with, implemented a kind of Lightning wallet. It's actually a remote control for a Lightning node that you run. Mm-hmm. So it's not directly a wallet in itself, but it looks like a wallet and it feels like a wallet. You just have to pair it to a full node that is running Lightning, and that's pretty easy to use, and so the usability is improving, and more of the Lightning developers and independent developers are making Lightning wallets, and of course there's now work on L2, the next iteration of Lightning, which improves some limitations that can sort of create usability problems today. So it's generating a lot of interest at the Bitcoin hackathon. The Lightning hackathons. Yeah. So apparently there's going to be another one in New York, I just heard. So that's pretty cool, and seems to be a very good level of energy, high rate of innovation and new developer involvement. And the Lightning network itself, of course, is growing like very fast in percentage terms. Mm-hmm. So that's cool too.
It took a long time, but I think it's on its way, and the debate's been settled. But what's the next big new debate in Bitcoin? Where will we go after scaling?
Well, I think privacy and fungibility is, in a way, a much more interesting and productive debate. So that could be an interesting one, and it's it is a trade-off because some types of privacy technology actually help scale. So Lightning is an example of that. It has off-chain transactions, so they're settled on-chain, but they don't create on-chain transactions for each off-chain transaction. Of course, so then information that would have gone on-chain is kind of coalesced off-chain. So that improves privacy. It has onion network encryption, so that's another form of privacy. So the other areas where you start to see a different trade-off, I guess Schnorr signature is another example. So generally making transactions look more uniform. So depending on how it's used, Schnorr signatures, which we might see in a while, people are working on it, mm-hmm. can make transactions look, like a multi-sig transaction could look the same as a single signature transaction. You benefit from aggregation. So there's a sort of fee incentive to aggregate by doing coin joins, which is a pretty cool incentive to see a financial reason to do coin joins, mm-hmm. other than just directly privacy. And some of the more ambitious things, which are further out, like confidential transactions, they have a side effect at the moment, although it's improving, of the transactions being much bigger, so like a kilobyte or two. Mm-hmm. So Bulletproofs does reduce that quite a bit and has log scaling, so that probably brings things within feasibility, but it has a different trade-off. So one of the trade-off discussions is whether in the far future event of a discrete log break, that there's sort of mathematical reason that you can either have perfect privacy. So if discrete log is broken, people still can't tell the value of the transactions. Mm-hmm. Confidential transactions just hides the values, not who's paying who. Mm-hmm. So in a discrete log break, you can have a choice of either the transaction values being leaked or people being able to print coins, which would kind of break the coin because the 21 million cap would be essentially gone. So people are arguing on both sides of that, and I think we need to see a resolution to that, and maybe some more sort of more efficient methods for doing it. So if people did decide that the inflation risk is okay for now, because you can always improve the tech later, right? You can increase the key sizes over time, or you can switch to, for example, post-quantum based proof systems yet to be developed. If you have confidence that the current discrete log assumption is good for let's say 10 years, 20 years, probably much longer, then you could potentially rely on improving that in the future. So that could kind of give you the best of both worlds: unconditional privacy and protection against inflation by improving the tech and the key sizes over time. So there's some pretty interesting technical consensus discussions and cryptographic size and verification cost optimizations that have to come. So actually we implemented confidential transactions in the Elements sidechain and in Liquid as well. The transactions are confidential by default. And actually Liquid has multiple asset types. So we used a similar technology to produce confidential assets, which also hides the type of the transaction. So you could have a transaction with one input, which is a US dollar, like something like a Tether or one of the competitors, and another input which is a Bitcoin. And so obviously because you can't have destruction or creation of value, there has to be at least one Bitcoin output and at least one US dollar output. But the confidential assets guarantees that you can it makes it hard to discover which is which. So you can verify that no coins of any of the types were created, and it's not readily observable which inputs correspond to which outputs in terms of type. So we have that implemented on the Liquid sidechain as well. So these things have scale trade-offs though, because the proofs are not small.
Yes. I know with confidential transactions, they say, if you're sending around $1 million, there's only a certain amount of people that have $1 million. You could limit the list that way. So it's about trying to guess backwards at who's sending the Bitcoin. So a lot of people say, why didn't Bitcoin just have privacy in the first place?
Well, that's an interesting question. So actually, when I first read about Bitcoin, so Hal Finney wrote a summary of how he tried it out and read the paper and wrote a summary of how it works. And so I read that before reading the paper, actually. And so the first thing that occurred to me is like, well, why didn't it use, there's a paper from, I think, 1995 or thereabouts on, what's it called, auditable electronic cash. So it's compatible with a public blockchain with no kind of central server private key. And so that was my kind of like, well, this is really not very private. You've got to recall that the previous electronic cash systems were somewhat centralized, but had really strong privacy guarantees. And Bitcoin had quite weak privacy guarantees, and still does. So that was my first reaction. But then, if you look at it over time, you realize, well, actually, that auditable electronic cash system, if you had implemented it, is quite computationally expensive. The proofs are quite big. And actually, that paper is cited by the ZeroCoin paper. So ZeroCoin is basically an optimization of that paper. So I had the kind of same instinct that other crypto-interested people did, which is, oh, that's an interesting way to add privacy to a Bitcoin-like system. So, I think the reason, your question there was, why didn't Bitcoin add privacy originally? I think the answer is it's actually quite challenging to do that. It's much easier to do it in a centralized system, but it's quite technically challenging to do it in a decentralized system with no central signer. So there was a sort of, it's a kind of known protocol limitation. Like there's no known efficient way to do this actually.
And as you said, currently at the current stage, Bitcoin does not have these features, but they can be upgraded. And now there is, of course, the technical side of the upgrade and also a economic side. So on the economic side, I would argue that the unchangeability of Bitcoin is really important because that distills the security of the 21 million cap.
Right.
But on the technical side, of course, we want to iterate. We want to improve the software because software is never perfect. Right. So what are the different upgrade mechanisms that we can use to improve and implement, for example, the CTs?
It's just about possible to do it as a soft fork. So there's 2 or 3 different ways. So Felix Weiss made a an outline proving, a kind of draft BIP proving it's possible, but it has some side effects when you move between regular Bitcoin transactions and the confidential versions. So when you take them out of the confidential version back to the regular Bitcoin, you have a 100 block delay, most probably. And Jonathan Lau had 2 or 3 other variants with different trade-offs, but it's not it's gonna not an ideal or smooth solution to soft fork. So obviously you can do more things with a hard fork, but maybe there's a reasonable trade-off to be found with more work in that area. Probably the bigger question is the sort of verification efficiency and the sizes. So another argument why it could be okay to make the trade-off is, so I'd made this argument in a presentation at one of the scaling conferences, that a confidential transaction is a more powerful transaction than a normal transaction, and so you might use less of them to achieve the same effect, or to achieve the same effect and to achieve it better. So I noticed that many people who do cold storage will break their storage up into like 100 fragments or 200 fragments. And so they've used 100 or 200 transactions. With CT, they could do it with one transaction, because they're, part of their reason is to not reveal the size of their savings when they go to buy, a hardware wallet online or something like that, right? So it would answer that problem. And then there are also reasons that people would do merge avoidance or make multiple transactions. So it can displace multiple non-confidential transactions, but probably still it's a size increase. And the other general observation is that with privacy, you want a large anonymity set. So ideally, a privacy feature should be used by everyone. Otherwise, you have the problem like with Zcash that, it has very good privacy, though, with quite a lot of cryptographic technical risk, but very few people are directly using it because it's expensive. And so you have privacy amongst a very small user set, in fact. And I think most of those are actually due to mining rather than use. So anyway, that's the same challenge.
I would just agree. That's what I've always said. What good is it if you're trading privacy coins with a network of criminals? You're trading dirty money for dirty money. You haven't really improved your system. You're just going to get caught for someone else's crime. We need it to be on the main network where we can kind of mask it so that everyone's using this privacy technology and that the field's big enough that you're actually trading for something that is cleaner than instead of just trading dirty money for dirty money.
Yeah, I think that fungibility is much harder to argue with. So, it's pretty fundamental that currency has to be fungible to be usable. And I think Bitcoin's fungibility is not as robust as many people would like it to be. You can see side effects with some exchanges that are actually worse than PayPal policies, which is one of the motivations, right? People will say, I got my PayPal account shut down because I did. Well,
even today, Alex Jones just got his PayPal account shut down. It's one of the last companies that went through YouTube, Twitter, Facebook, and now it's on to PayPal. And people always say Julian Assange, of course, as well with WikiLeaks. Anything that people don't like, you can't donate to with PayPal or Visa. That's why a system like Bitcoin would be better, where you can choose where you want to send your money.
Right, exactly. So, the other kind of wider... So, people find out that fungibility is important the hard way. It's kind of like an insurance policy, right? Yeah. But then at least they do have some recourse, which is they can switch to Bitcoin. And I guess in the case of WikiLeaks, that worked out extremely well because Bitcoin price appreciated by probably 100-fold since they started accepting donations in Bitcoin. But the other example was Operation Choke Point in the US a few years ago, which was basically to deprive people of banking services, not for illegal actions, but just for actions that the establishment didn't approve of. So that's kind of extra legal behavior. So I think Bitcoin is good as a kind of counter to that, and it may help keep the system honest as well, right? If people see that doing, if the establishment sees that doing things like Operation Choke Point has the side effect of getting more people to use Bitcoin and use Lightning, which is faster, then maybe they'll slow down on those kind of activities, which will also be a good side effect.
Yes, and here on the World Crypto Network, we've talked for hours to Adam Nopara about the amazing Wasabi wallet. And I was quite surprised on how much privacy and anonymity you can get with the current implementation of Bitcoin on, let's say, the level of the wallet. So could you maybe go a bit into the differences on the privacy in the base protocol and privacy on top with, for example, the user interface?
Yeah, I mean, there are limits to what you can do because, for example, like a coin join, if you're not careful, the amounts can be unique, so that it can void. So it seems like historically many of the claimed coin joins were not actually adding any value due to, not analyzing the statistical or change kind of breaking. And some of it's more subtle, like, there's some change that comes out of it, but then you commingle the change with something else, so your previous transaction is not as private as you thought. You kind of undo the benefit. But I do think it's interesting to do it in a wallet as opposed to on a service. It's more of a peer-to-peer thing with users, collectively doing things using a peer-to-peer protocol. So some people, including Nopara and myself and a few other people, participated in kind of hackathon to think about protocol ways to do more peer-to-peer joining, basically. And so there's a kind of loose. It's actually quite challenging as like the main outcome of that multi-day discussion. And so it was like, okay, let's improve it incrementally. What can we do that adds some value? And so there was a pay-to-endpoint proposal, which could be implemented. It's basically the idea that if you pay a merchant, it's a good opportunity for the merchant to basically do change consolidation and join with your payment. So the merchant is an input into the join. And so from the outside, you can't really tell, because the amounts are naturally imbalanced because you're making a payment, right? So it kind of breaks the value association. I mean, the general aim is to make it less apparent. I mean, there's an assumption that people are doing when they try to analyze the blockchain that the inputs into a transaction all belong to one wallet. And so things which make that a less reliable heuristic improve fungibility a little bit. So, there are multiple variants of CoinJoin using cryptography in between that doesn't go on the blockchain to assure that neither party can kind of renege on a transaction partway through. So anyway, I think that stuff is pretty cool, but it's also limited. And so confidential transactions, again, one of the very positive benefits of that is the change issue goes away, because basically any join is a perfect join because, you don't see the values, basically.
And maybe one additional feature that the Wasabi wallet provided was precise labeling of the UTXOs and precise coin selection. And of course, the reasoning behind this is that you do not want to intermix your anonymous UTXOs that you think are quite anonymous and those that are more public. Would confidential transactions solve this issue of having to take care of these several UTXOs?
Not directly. So, I mean, actually, confidential transactions doesn't at all hide which coin is being spent to which output. It just makes it very strongly ambiguous as to which output is change. And it makes joining much simpler because you can join anything with full benefit. But, change selection and using different wallets or sub-wallets for different purposes is still going to be necessary, I would say.
And is there anything new that you're working on at Blockstream right now, or anything you're working on right now that you'd like to tell the people about?
We're working on lots of different things. So the Bitcoin satellite project is progressing. So we'll have some more updates in some time on that project. The Green Dress wallet is making a lot of changes. So at the conference today, Lawrence mentioned that there's a user interface redesign that will be released soon, and it's also switching from end-lock time to CSV, which is better for privacy. I mean, the end-lock time feature, which is pretty cool in providing a two-factor authentication without having to trust the server, the service provider. It still has the problem that you have to receive the end-lock transaction, and the way that that's done, because the user could lose their smartphone anytime is that you need to sign up with an email address and receive the end lock. So people will sometimes lose control of the email address, or they will accidentally delete it or lose the device. And so with switching to CSV, which is implemented now, or will be switched over to in a while, the lock time is directly part of the smart contract. So that was only possible with the introduction of CSV, which itself was strongly motivated by supporting more efficient forms of Lightning. So that's positive, and it's we're going to switch to that pretty soon.
All right, great. Thank you so much for spending time with us, and thank you for what you do at Blockstream.
So, I mean, the other thing that we've been working on is Liquid. So we'll have some pretty big Liquid announcements coming up soon with exchanges participating, and that brings confidential transactions live and helps. I think it's just another input into improving liquidity in the Bitcoin market. So that sometimes gets in the way of some use cases because people run out of liquidity when they do medium, larger size remittances or international payments. And actually, sort of weak liquidity has been one of the comments on ETFs and things like that.
Yes. Okay, and then thank you very much for talking to us again, and thank you for what you're doing here with Bitcoin. And maybe as a short little exit question, what motivates you? Why are you doing this?
Well, I'm just another Bitcoin believer, basically. Bitcoin is super interesting. I was for many years, even before Bitcoin, interested in the intersection between technology, cryptography, and improving sort of the balance of power for users. So things like PGP and Tor and the previous electronic cash systems. So I think that's very interesting to see and help be part of the future potential for Bitcoin.
All right. Thank you so much. Adam Back from Blockstream.